Imagine looking out across this barren red dirt, asking a practical question. What does it take to build a permanent, self-sustaining city here? To keep humans alive in an environment with no breathable air and lethal radiation, you need incredibly heavy infrastructure. We're talking thick radiation shielding, highly pressurized habitats, acres of solar arrays, and massive industrial water recycling machinery. Look at the sheer mass involved. You have to physically move millions of tons of steel, food, and complex equipment across millions of miles of empty vacuum. Just to keep a baseline population of 100 people breathing, you need redundant oxygen generators, carbon dioxide scrubbers, thermal control loops, and backup power grids stacked on top of backup power grids. Establishing a permanent human presence on Mars relies on solving a massive logistics supply chain problem. But the way we have historically traveled to space makes moving that volume of cargo impossible. For decades, rockets were built at immense expense, flown exactly once, and left to burn up in the atmosphere or crash into the ocean. Imagine flying New York to London, and the airline throws the 747 away. A ticket would cost tens of millions. This chart shows the result. With disposable rockets, shipping 1 kilogram to orbit commanded an astronomically high price. Under a disposable transport model, shipping the millions of tons required for a Martian colony would literally bankrupt Earth. The math here simply does not work. Engineers at SPACEX recognized this economic roadblock early on. Their solution was straightforward in theory, but brutally difficult in practice. Rapid rocket reusability. Stop throwing the vehicles away. They spent years trying to figure out how to precisely control a 14-story aluminum cylinder. They built prototypes, flew them, watched them explode, analyzed the flight data, and rebuilt them. Test, fail, fix, repeat. A moment of wonder. Eventually, the math caught up with the physics. A massive orbital booster returned from the edge of space, reignited its engines, and landed perfectly intact on a small platform in the middle of the ocean. Once they started successfully recovering and reflying these Falcon 9 first stages, the cost to put payloads into orbit plummeted. The most expensive part of the rocket was no longer ending up at the bottom of the sea. By solving recovery, spaceflight evolved from a bespoke government megaproject into a viable, routine commercial freight operation. But the Falcon 9 is only partially reusable, and physically it is too small to transport the millions of tons of heavy cargo required to build a city on Mars. That requires a completely different scale of engineering. This is Starship. It is the largest flying object ever constructed, designed from the ground up to be entirely reusable. To hit the required turnaround times, the hardware had to evolve. Instead of deploying landing legs, the heavy booster descends backward out of the sky and is caught by mechanical arms directly on the launch pad, ready to be refueled and flown again. This line graph projects the cost of access to space over time. If a fully reusable heavy-lift vehicle like Starship operates as designed, the launch cost per kilogram drops down a sheer cliff. Starship provides the heavy lift capacity needed to operate a supply chain at a planetary scale. Let's go back to those millions of tons of steel, solar panels, and water recyclers needed for human survival. Suddenly, with a reusable architecture, the math starts to work. The operational vision involves fleets of vehicles, each carrying over 100 tons of cargo, launching multiple times a day from scattered platforms globally. That routine, high-volume shipping capacity means you can finally transport heavy pressurized habitats and massive industrial water treatment plants without worrying about strict weight limits. Engineers no longer spend billions designing hyper-lightweight miniature rovers. Instead, you can buy standard, bulky, heavy industrial machinery and tractors here on Earth, load them directly into the payload bay, and ship them straight to the Martian surface. By solving the brutal engineering challenge of rapid rocket reusability, SpaceX is systematically destroying the economic barriers of spaceflight. They are building the deep space freight infrastructure required to make a